Hi, welcome to this video. My name is Phil and I'm a senior lecturer in astrophysics at the University of Lincoln, and I want to use this video to have a look at the different sorts of comets that there are. Now maybe you know what a comet is, maybe you've even seen one yourself in the sky, and if you have, they're quite exciting to see. But there are a few different sorts of comets and it depends kind of where they come from and things like that. Now I'm only going to cover kind of like the main types of comet here. There are obviously other types and other subcategories and stuff, but I'm going to cover kind of the main ones, the ones that we might actually kind of get to see if they come near us. So firstly, what are comets if you're not particularly familiar with them? Well, these are kind of icy objects that generally come from the outer solar system. They definitely come from further out than where we're located. So here is a kind of logarithmic side edge-on view of the solar system. We've also got the sun at the centre. We've then got all of the planets, the inner solar system. And you've kind of got Voyager there, which is quite a way out. We have the Kuiper Belt, the scattered disk, which is kind of just beyond, or not just beyond. Voyager 1 is kind of in and around that sort of area, just beyond it really. And then we have this Oort Cloud. Now from the Kuiper Belt onwards, which is kind of where Voyager 1 is kind of shown here, or just beyond Neptune actually, if we're being honest, all the way to the outer edge of the Oort Cloud is where these icy objects, these comets, are likely going to be coming from. And there's a whole collection of them there. And the Oort Cloud is kind of like this spherical object. Not an object, I suppose, but it's this spherical structure in the outer part of the solar system that goes all the way out almost to our nearest star, Alpha Centauri, Alpha, and basically those sort of things there. So, comets in general have very elliptical orbits. They're not like planets and asteroids. They typically have more circular orbits, so they don't really move much with regards to distances between the sun. So, okay, the Earth has a very slightly elliptical orbit, so it gets further and closer to the sun as it goes around on its orbit. But comets are exaggerated considerably more than that. And, well, I say exaggerated, they are a lot more elliptical. So they get very close to the sun and then they get very far from the sun. So very elliptical, very high eccentricity. So that is very different to what we would have with a planet or an asteroid. Now, as they come into the inner part of the solar system, that's when they start to produce their tail. Because they're kind of icy, they're more volatile compounds. As they get closer to the sun, they warm up, and then they produce these tails. And I say tails because actually the comet themselves, an individual comet will have multiple tails. It may have like a gas tail, an actual dust tail, and things like that. And they all kind of point in different directions depending on the solar wind and the direction of the orbit. So they do have multiple tails, but that is produced as they get towards the inner part of the solar system where the planets are. They don't have those tails further out. So different sorts of comets. These are kind of ones that I'm going to vaguely kind of mention really here. You've got short period ones, you've got long period, periodic, non-periodic, which are kind of like hyperbolic ones or very near parabolic, and you've got sun grazers as well. So these are kind of a few types that I'm just going to cover here. There are obviously other types here, like there's unclassified ones, there's kind of like historic ones, things like that have different kind of classifications. And actually some of the non-periodic ones, the hyperbolic ones, are also going to be things like interstellar comets. These are comets that have not come from the solar system. So short period comets then. So here's an example of 1P Halley, and this has an orbital period of about 75 years. That's a nice picture of it there. And these short period comets have orbital periods less than 200 years. So these take less than 200 years to go around the sun, which is still a long orbital period considering we take 1 year. So there's still a long way out in the solar system, but these are on the short end of orbital periods for comets. Now, where do they originate from? Well, if we've got all of our planets in the inner solar system here, Neptune is kind of at the outer edge of our planets, and then we have the Kuiper Belt and the scattered disk. And these short period comets generally come from those locations there. So these are kind of like they're not really flat disks. They've got some kind of vertical structure to them, but it's where Pluto is essentially, and it's a collection of all these smaller objects and the objects that get knocked off their circular orbits and they go into the inner part of the solar system. So they come from the Kuiper Belt or scattered disk in general for these short period comets. Now, they can also be periodic. So short period comets can also be periodic comets. What do we mean by that? Well, it means they've got predictable orbits and we may have observed them more than once. So if they've got a fairly short orbital period, we've actually seen them multiple times. They've come from multiple passes around the sun, so we would classify that as a periodic comet. We can predict their orbit relatively well because we've seen them multiple times and they have a fairly short orbital period. Now, long period comets. So here we've got C2007 Lovejoy. This has an orbital period of about 50,000 years, but long period comets have orbital periods generally greater than 200 years, so considerably more than what we would have for a short period comet. And these typically originate from the Oort Cloud or from the very outer edge of like the scattered disk and that. So these are from the very far outer reaches of our solar system. They come from much further away this time around. It also means because they're further away from the sun, they're travelling slower, larger orbital radiuses, they're going to have much longer orbital periods. So in general, they typically come from like the outer regions, and they can come from the outer regions of the Kuiper Belt and the scattered disk, as well as the Oort Cloud. So if they're kind of on the lower end of the orbital period, so just over 200 years, they're more likely going to have originated from the scattered disk, the Kuiper Belt, instead of the Oort Cloud. But anywhere from that sort of range is where they're likely going to come from. Now, if they're in the Oort Cloud, so these are ones that are the furthest away from us, right at the edge of the Oort Cloud, these can have orbital periods of up to 1 million years. And you can see straight away, it's quite unlikely that we're going to have observed those multiple times and got detailed measurements of them with such long orbital periods. And at the very far edge there, they're also almost like a light year away. So not only have they got a very long orbital period, they're an incredible distance away from the sun. So almost a light year away. That's the very far reaches of our solar system. So they've come from a very long way. Now these can actually be classified also as non-periodic comets. So here they don't have predictable orbits. They're unpredictable because we've typically only observed them once. They've only had one passage past the sun. So we've only seen them come into the inner solar system once. Therefore, we would classify that as a non-periodic comet, as well as being a long-period comet. Now, we also have hyperbolic and near-parabolic comets. These are quite likely not going to have originated from the solar system. They could be from the very, very, very outer Oort cloud, but these are comets that don't necessarily have a closed orbit. So they will basically pass by the sun and they'll kind of go off in a curved trajectory. They won't come back round again. So it's quite likely that some of these, if not all of them, are going to be originating from outside of our solar system. These will not be solar system comets, which is quite interesting. Now, two examples here actually is we've got Borisov and Oumuamua. Both of these quite recently came from outside of the solar system. They came in on these hyperbolic orbits quite fast, round the sun and then back out again. How do we know that they were not from the solar system? Well, they were travelling too fast, so they weren't gravitationally captured by the sun, and just their trajectories, basically. So they were essentially not on closed orbits. So these are likely going to be like your hyperbolic ones, and they can come from outside the solar system. Now, we then also have sun-grazing comets. So when you have a very elliptical orbit, it means that the distances, the maximum distance and the minimum distance, so you're going to have like the pericenter, apocenter, they are going to get more extreme the more elliptical the orbit gets. So when you get very, very elliptical comets, when they make that close pass to the sun, they're very close. They can almost pass through the actual atmosphere of the sun, and they don't always survive. And we will classify these as sun-grazing comets because they do literally graze almost the surface of the sun, and they will lose their tail. Sometimes they actually just plunge into the sun and you never see them again. Sometimes they survive, but they get disintegrated and they'll come back around again, and then that comet's in multiple different pieces, which actually gives rise to things like meteor showers. Close passages to the sun can break them up, and then you end up with a debris trail that we pass through each year, which gives us our meteor showers. So these ones don't always survive because they're so close to the sun. And here's an example actually. So you can see that there. That one's travelling very close to the sun. It's picked up by one of the solar telescopes in space, and a lot of the time the tail gets blown away. And sometimes, again, they'll actually pass through the atmosphere of the sun and they just don't survive and they actually plunge into the sun itself. So thank you for watching, and if you enjoy the videos or find them helpful, then do consider becoming a member. There's extra videos in the member section, but it also helps support the channel as well. So thank you for watching.